Hello, this is Mario from Windtunnel 24. A warm welcome from our facility, and we just wanted today show you the Windtunnel WT342. It's a wind tunnel we exactly in this day we finish this, and tomorrow we ship this to our customer in Oslo, Norway. It's a metropolitan university there. The reason for the wind tunnel of why the customer just gets this is they want to make education with this for the students there in Oslo. We have different kinds of wind tunnel which we are building. It's the open wind tunnel, the closed loop wind tunnel, and it's a blowdown wind tunnel. This open loop wind tunnel is kind of sucking the air through the whole wind tunnel and blow it out into the room. The wind tunnel has a dimension of the test section. Here it's 400 by 400 millimeters. We have a top speed of 37 meters per second. And we have a turbulence level intensity in the sweet spot area of about 75% of the test section is lower than 0.3%. The whole unit is made to be transportable in the university or in the test facility. It's on rollers, so you can shift it everywhere, and it's a plug with 16 amperes or with 32 amperes for connecting it for the electrical power. Now I want to show you some parts of some details of our wind tunnel. So we go first to the settling segment. The settling is starting here with the honeycomb section. We have honeycomb tubes with a diameter to length ratio, so diameter of the tubes to length bigger than 9. This is necessary to get all the curl out of the incoming air. And then we have 4 screens. We made them out of stainless steel screens. This is wire screens. We just stretch them very hard and have very hard stretch screens here inside. So there's no vibration or there's no really bending where the wind comes through. The 4 screens bring down the turbulence level quite low, so it goes down and down and down with every screen we have, and the uniformity gets better and better after each screen. In this section, we have these cleaning tabs. You can open it, go inside, hoover it, and bring the dust out, which you may have sucked in during the time. Next section is the nozzle. We have a contraction of 9. It's the 5th order bending form which we use. The wind comes slow in and speed up by factor of 9, and then goes directly into the test section. Test section have 2 glass sidewalls and a mounted, normally we have also a glass wall on the top, but here is a traverse system mounted for getting some values, but I will tell you later on that. So the test section, you can see is the glass is visible from bottom to top, so you can see over the whole range. In the middle, this is a long test section. We have the application within window, which you can open, and there are some gas damping instrument there, so you can open it. You see here inside, it's a plate which is removable. There you can mount models. You also can get it with an integrated wind tunnel scale. We have a three-dimensional wind tunnel scale and a 6-dimensional. So 6-dimensional means 3 forces and 3 moments. Also a mechanism to turn models. They are possible. So just clean it or close it. So it's a long test section. We also have it as short. The long test section has the possibility, the customer has the possibility to see the wind afterwards and see the development of wind. Also, it's possible to turn it around and then put this test plate for some boundary layer test or other stuff to that area there in the back. So now let's have a look on the traverse system. This is a one-dimensional traverse system. It is possible to go through different positions. You can program it. You can make it's part of the program of the whole wind tunnel. I later will say something to that. But this one-dimensional is one dimension this direction, but manually you could also move these in wind direction. So we have a position after the model where you can get all the values. And normally you connect a hot wire or a Pitottube on the traverse system. So let's go ahead. Here's a diffuser which comes after the test section and makes a flow from rectangular or square flow to circle flow for the fan. This has an integrated sound damping system. So we are at the moment at the 20 meters per second. We are at 71 decibel. At 30 meters per second, we are outside here at 81 dBA, and at top speed, of course, it goes really up. We are at 89 dBA. So, sound damping system at before the fan and after the fan. And the fan is completely disconnected to the rest of the framing of the wind tunnel. So here it's standing on springs, and here it's disconnected by elements, soft elements. Okay, so then I will show you now the control unit. So the control is here. This is something like the main computer has a touch play where you can set values like how fast you want to have the wind tunnel, or at what speed you want to rotate the fan. The control can then calculate all the things on its own and let the wind tunnel run. But there are also sensors integrated to find out how fast this is. So first, here's a Pitottube. It's a 3 millimeter tube at the beginning of the test section where we get the pressure. And also we have integrated in the wind tunnel temperature, humidity, and absolute pressure. And with these values, we calculate the wind speed. This one could also be connected to a customer computer by something like a remote connection. But with this software on the computer, you are able to write programs to make something like sequences. So you can say what wind speed you want, where the traverse system should go, how many values it should take with a pressure sensor or with a pressure scanner, which kind of forces you want to know. This is possible with a software packet, so you get all the wind tunnel data together and all the data from the wind tunnel. So it's a data acquisition system, but also a system for make your own sequences. To run it through. This is normally the pain that you have to very long measuring cycles every time the same. But this is here an automated system. You can program this and have it all the time the same way. So this was it from the wind tunnel WT342. It's going to Oslo. We say good luck and also good values of the experiments in Oslo, and say goodbye here from Germany. Bye-bye.